Let's talk about IBIS quality checking. So basically, my mantra for IBIS quality checking is this: validate, simulate, correlate. It's pretty easy, okay? That's all you need to know. Now, I'm not going to go into all the details of this in this coffee break video. I'm actually going to do a whiteboard video later on that's going to go into more depth in the details. But when I think about IBIS quality checking, like I said, I start at the validation stage, okay? So your first step is to run the IBIS parser. That's going to be your first line of defense. That's going to get rid of any of the easy errors or issues. Then the next step within the validate framework is really model quality checking. And you have to go beyond the IBIS parser to do that. Now the way that I do it, and the way that I designed it into the IBIS DRC tool, is I actually take information from the data sheet from your I/O buffer or your full chip, and I create a spec file of that. So I kind of put a layer on top of the IBIS parser specification, and those two combined kind of give you a complete IBIS quality checking for your model. So you can check things like, what's the maximum data rate that your I/O can simulate? What's the maximum frequency that it can run at? Let's look at the edge rates. Let's look at the output impedance. And then we'll also check some of the more standard things that should be inside an IBIS model. For example, like the AC timing load, or the receiver input high and low voltage thresholds, things like that. So you can kind of wrap all those together in the framework. Let me give you a specific example. Let's say you're using, a post layout tool, whether it's from Cadence or Mentor, and you want to do a DDR3 design. Now there's some keywords that are designed within the IBIS framework called receiver thresholds. And a lot of the DDR wizards or DDR, post layout tools use those keywords to do the calculations for your skews and your delays. Now you need to have those in the right place, in the right order in your IBIS model. So you could take things like that and put those into your framework checklist in your validation stage, and that'll help you make sure that you've got a good IBIS model. Now the simulate part is pretty easy to understand, right? You should always simulate your IBIS model before you do your full signal integrity simulation. Now the reason you want to do that is because if you've got a full, say, memory interface, a 64-bit memory interface, and you start running simulations and maybe it takes an hour, a couple hours to chug through all that and crank through, you might get an error or warning, but now you don't know where it is. Is it your S parameter model, is it the board extraction, or is it within the IBIS model file? So if you do this type of process flow I'm talking about, validate, simulate, correlate, you can eliminate the fact that the IBIS model is causing you problems in all of your simulations. And the final piece is the correlation piece. And this is really about, even though you've validated your IBIS model and you've simulated it and it seems like it's matching up to your datasheet specifications and what you think it's going to be, you really want to correlate it back to something as original source, or something that is sort of a good source item. Sometimes people call this like a golden waveform or a golden correlation, right? So you can correlate it back to an original SPICE model, or you can actually go in the lab yourself on a demo or an eval board and take some measured data and correlate it to that. Now ideally, you'd like to get the correlation data from the IC vendor, right? Because they're the ones generating the models, they're the ones who understand the data framework of generating the model, and that would be the best place to get your correlation data. So always ask your IC vendor for correlation data. Now if you can't get that, again, you can go into the lab and take some basic measurements and use that as a rough correlation. Or if you can get a hold of the SPICE model, you can run simulations and correlate your IBIS model to that. So that's kind of what a whole framework would be when I talk about checking the quality of your IBIS models.
So I'm going to walk you through the IBIS quality check flow I just described using the IBIS DRC tool. So the first thing we want to do is run the IBIS parser, right? So this is the IBIS check tool, and in here you can see we've got no errors. So this is your first line of defense. If you had any warnings or errors, notes are fine. Warnings or errors, and you need to stop and figure out what's going on. So this passes a parser, so now we need to go on to the next step. Now, I also like to check the package pins, because this is part of the overall quality framework that you should have. Now, in IBIS DRC, what I do is I allow the user to upload a spec file that basically just has the package pinouts, and it describes, whether it's an I/O, an input, an output. So what I'm going to do is I'm going to load up the wrong one and show you the check, right? So what you should see is pin 1 should be an output model, and here pin 1 is assigned to ground. Now it's important to have your package pin out right, because when you do a post layout in your board simulation tool, if things don't match up, you'll get errors or won't simulate right. So this is another level of checking that you should really do. Now once you have your package pin out all set, then we can go and run model quality checks. Now before, like I was saying, you can figure out what pieces that you need to set up in. And so the way that I've designed IBIS DRC, as you can see here, is I have this spec file data, and this is really based on the data sheet. And you can put in all sorts of things here, like what you want the package impedance to be, the die capacitance, the specified I/O voltage range, pull down and pull up impedance. And this is actually just a snapshot of the different checks. So IBIS DRC has like over 75 checks. Now, if I look at a different spec file, not based on this data sheet, but say a DDR one, you can see that it shows me red. So it's already showing me there's errors. And so I kind of use this as a quick way to get my spec file set up. But let's use the right one. You can see that it's all passing. And then when I run the quality checker, this runs all the checks. And you can see here I've got no failed, okay? And then if we go and we open up the report, you know, it's going to give you a bunch of different header information. But really what's important is to go down through here and look through all these checks and to make sure that you don't have any fails. And it'll tell you right here that there's no fails and no exceptions, and it actually assigns a quality level based on the IBIS quality sub-framework. And so that's kind of what I was talking about, of rolling in all of your checks into one major framework. And of course, IBIS DRC automatically does it for you. Now, the last piece is the simulation and the correlation. And so in this instance, I've already have this set up. So what I'm going to do is I'm going to simulate the output load, just a typical corner, within this defined test load. And I didn't talk about this in the previous section of the video, but there's actually this test data waveform, so you can actually store your correlation data within the IBIS model file. And this is how I do it within IBIS DRC. So what we're going to do is, you know, we're going to run the IBIS model into this test load, and then we're going to take a look at the data. So if we come in here and I open up the sample correlation of this IBIS model file, so you can see here that I'm running multiple pulses here, and I'm showing, you know, both of it, you know, starting with the rising edge and the falling edge. And you can see here that these are the metrics I'm looking at, the low and the high, and the rise and the fall. Now I don't put the duty cycle in here because I can look at it within the waveform viewer. And if you have the correlation data of either the SPICE model or lab data stored within the IBIS model under the test data framework, like I do in this example, then you can load it up, and here you can see that it overlays perfectly for the typical corner. You have no errors, and so now you know you have got a simulated and correlated model, and it's good to go. And of course, you can save all this data within IBIS DRC, and you can actually create this create a final report.
Thanks for joining me today for this coffee break video. I hope you enjoyed it. If you have any questions or feedback, or if you have a topic that you'd like me to discuss next time, send me an email at tim@signalbytestech.com, and be sure to join us online at signalbytestech.com. Sign up for our newsletter, be notified when we do another one of these videos. Now, I'm going to have another cup of coffee, and it's probably time for you to get back to work. I'll see you next time.